G'day everyone, in this video here we're going to be looking at finding the derivative using first principles. So here we have how we actually do this, and this is just in the purple in the top right hand corner. So to actually find the derivative f dash x here, we need to find the limit as h approaches 0 of fx plus h minus fx all over h. So this is what we need to do here. So in both of these questions we've been giving a function, so fx. So with this we now know what fx is. We need to work out what fx plus h is. So fx plus h. So we need to work out what this is. So we just add h wherever the x is. So in our first one here, this is equal to 4 times x plus h, because it's normally 4 just times x. So we can expand this out, and this is really useful for later, so it's always good to expand out when you are doing this just at the start, because you need to do it later if you're working it out by hand, which is 4x, let's do that one again, which is 4x plus 4h. Okay? So that's what fx plus h is. So we have x plus h, we have fx, so now we can actually use this to work it out. So our derivative, f dash x, is equal to the limit as h approaches 0 of fx plus h, which is our 4x plus 4h that we just worked out, minus our fx, which is 4x. I always just put brackets there because when they do get longer, like in the next one, you'll see it. And this is all over h. So hopefully you'll see on the top we actually have two things that can cancel out. So on the top we have 4x minus 4x is 0, so they cancel out there. And we're just left with 4h over h. So f dash x is equal to the limit as h approaches 0 of 4h over h. And then you'll see 4h divided by h. The h's actually can cancel out in this. So get rid of that, and we actually just have 0. So we don't actually need to work out the limit as h approaches 0. We just have 4. So we don't need to work out the limit as h approaches 0 because we just have 4 left over. We have no h's to work out the limit. So the limit is just equal to 4. And that is our derivative. So we've worked out this first one. Now onto the second one here. This one's got a bit longer, and it just has more variables to deal with. So we need to do the same thing, find fx plus h. And this one's going to be a bit longer. So this is equal to 3x plus h squared plus 4x plus h plus 3. Okay, I'm going to expand this out. You can always use your CAS to help expand if you do have ones to the power. So x plus h squared though is equal to x squared plus 2xh plus h squared, and then you multiply that by 3. So if you're alright with expanding just your first one there, you can do that, or you can use your CAS to help if you're just a little bit unsure. So I'm just going to do this all in one step. So this makes 3x squared plus 6xh plus 3h squared. So that's our first one, that's this one, just here, expanded. And then we've got plus 4x plus 4h plus 3. So we've got all that, and that's our fx plus h. So we do the exact same thing. We use the formula that's above, highlighted in green. Hopefully I'll have enough room for this. F dash x is equal to the limit as h approaches 0. And this is all over, I have to write this a little bit smaller, 3x squared plus 6xh plus 3h squared. So just writing what's above. Alright, and then we need to minus our fx, which is up the top here. And I'm just putting that in brackets so we get all the right signs. Alright, so we've got this here, and hopefully you'll notice, and you get in a good pattern of this, you'll notice all the terms with just x will cancel out if you've done it right. Oh, sorry, this is all over h. So all the terms with just x will cancel out. So we've got our 3x squared here, and we're minusing 3x squared here. So that cancels out. So we've got positive 4x here, and minus 4x here, because we're minusing a positive. Then we've got our constant that also cancels out here. We've got positive 3 minus 3. So if you're doing this right, you'll notice that all your fx will cancel out up the top, and you'll be just left with terms with h in it. So I'm just going to write this out again with our simplified derivative of x is equal to the limit as h approaches 0, and it's always important to write that limit as h approaches 0 there, of we've got 6xh plus 3h squared plus 4h, it's a funny h, all over h. So now you will notice this as well, there will be h terms all above, so you can cancel out this h on the bottom, because if you're dividing by 0 it doesn't work. So you'll always be able to cancel out this h on the bottom with the h terms above it. So that cancels out that to leave 4, that cancels out that to leave 3h, that cancels out that to leave 6x. So I'll write that out again. So this leaves 6x plus 3h plus 4. And now we need to do our limit as h approaches 0. So we just need to substitute every h value for 0. So f dash x. So I'm just substituting in, I'm just doing this over here. This will make it 3 times 0, which is equal to 0. So we just don't need to write that one term. So f dash x is equal to 6x plus 4. And that is your final answer there. So just be aware of the steps here. You first need to find your fx plus h and expand it if you're doing it by hand. Yet again, you can put this into your CAS if you define it all, and it's a lot less steps. So find your fx plus h. So expand and simplify. So there's these two steps here. Simplify, and then hopefully you'll be left with just some terms here that with x or h as well, or a constant. So left with something there, and then you put your limit as h approaches 0 to get rid of all the h terms, and that will leave your final derivative. So hopefully this helps with finding the derivative by first principles, and good luck.